we are going to learn about data consistency patterns. This is one kind of a pattern which is introduced in microservice architecture to maintain the consistency among the databases. Because every transaction while you perform, there are different updates which is going to happen in different end of services. So each service having its own data store and other database where there should not be any duplicates, and the stable data entry is supposed to be maintained. So in microservice architecture there are different patterns which are proposed. The main type of pattern name is called the Saga, and today we are going to look at what is Saga and what are the problems with traditional monolithic software based application. When the developers develop, what are the problems they are facing and how this is overcome by the microservice based data storage with the help of this kind of a patterns when it is introduced in data storage. So first of all, we should know about what is data consistency. Data consistency means, okay, so while you perform in an database management system, each and every module, consider here stock module, payment module, order module will be there. So each module in a monolithic application architectural style, everything will be updated in a one single data store. And so here commit and rollback is possible and it is easy. When you go for microservice based architecture, each services are maintaining its are updating the data in a separate database, and each service are requested that updates is happening in that particular database, and when but that is connected with the next kind of service as well. But every databases are supposed to be maintained in a uniform manner, because every updates are supposed to be up to date as well as accurate across all these systems and all the databases. Then only the people will trust the application and they will maintain and to perform reliable as well as day-to-day valid application for any kind of events. So this data consistency prevents conflicting informations and ensuring that all the copies of the data which are available in different databases are same. So that is why data consistency is important while you consider in monolithic compared to monolithic microservice architecture, this kind of problems may come. So how to overcome such kind of problems? In normal traditional architectural styles, we are using this are following the ACID property. But the developers use the ACID property for developing the databases. So what is ACID property? Atomicity, consistency, isolation, and durability. So these are the properties which are supposed to be to be included and to be followed on each transaction which is performing, or when you perform any transaction or accessing the data. As per this, that databases are supposed to be updated. So what is meant by atomicity? Atomicity means each transaction is treated as a single unit, which either success or completely fails. So this is how. What is meant by Saga pattern? Saga pattern, it's an architectural style and which is for maintaining the distributed task which is performed by different databases, that is done by different kind of a microservice through which this data transactions are going to be reflected back in the databases. So it is it's supporting for a distributed architectural style. So there are different databases are going to be there, and when a customer requests for a particular service, each service which is going to perform a certain task, but the same data is going to be maintained among different databases. So that is called Saga pattern. For example, here there are different kind of tasks, like the user may request for order service, or okay, payment service, inventory service, shipping service, and notification. So when user come for creating an order, what next is going to be happen, but everything is going to update in a particular database uniformly. So that is called Saga pattern. So Saga pattern permits user to perform and access different databases, and to perform a distributed task, but each transactions are coordinated in between this kind of multiple services. So that is called Saga pattern. There are problems occur during the transaction management process because the database is distributed and which is available and maintained by different data center. So there is a possibility for duplicate data entry may be there. Sometimes the updates may not happen. The order, because sometimes the payment module is not available, the server is restarted or it is updated. Because of that, during the time when order request is raised, it may not be processed properly, or the user may have done the transaction, but at the time the server was booted or some restarting part, this updation is not reflected back. So at the time, with the help of this ACID transaction properties and with the help of these features, okay, each and every transaction queries which is raised by the customers are supposed to be looked after, and you have to track what happened in between that order and the transaction process. So why that order is rejected or accepted, so you have to find out and you have to quickly recover this kind of a problem with the help of data resiliency. So what is data resiliency? It's an ability of an organization to maintain or quickly recover the data accessibility, integrity, and availability in the face of unexpected events. Maybe because of natural disaster, the data center is not updated with the, but the backup will be there. So what time, what transaction made by the customer should be rolled back, and so you have to recover and you have to satisfy the customer with the help of this kind of but there is a problem with the transaction management of traditional monolithic kind of an architectural style when it is followed. So here the system, if the system is generated a particular event back to the customer each and every time of transaction, when for example when you logged in, immediate notification sent back to the mail, or in terms of messages, the customer may get an acknowledgement that okay, successfully logged in, and the event is also generated back, and to get more confirmation and about safety and security of the application, preventing from unauthorized access. When they initiated a withdrawal transaction, so that confirmation is also supposed to be, so you have raised a request for withdrawing this much amount, okay, so that is also confirmed. And the next process when they initiated, okay, so are you confirming that withdrawal of this much from this balance of okay, press OTP or enter OTP or press yes or no. Such kind of messages communicated back will ensure each and every step the customers are connected with the system properly, and each and every time the transaction is updated back. So this gives an assurance to the customer that okay, their transactions are going on well in the right direction, and their shipment and payment, all the transaction details, like one by one step, every acknowledgement when it is connected back with the customer's device, then it is easy for them to access. So this kind of a transaction mechanism is connected with Saga pattern, but which is not available with the monolithic architecture and the traditional transaction management system. So Saga is based on event based management system. So mostly it will be useful for financial transactions. So it reduces a lot of problems which comes in between the financial transactions. With the help of Saga, this kind of a pattern will help the developers to track and isolate certain kind of problems and produce a good solution to the people's need. Um, so the transaction management in microservice architecture, we are going to study more. So far we have studied about what is the ACID property and how they have implemented in a monolithic based architectural style, and what is the problem, and how can you recover from the problem with the help of this microservice architecture style when you follow with the help of a Saga. So just an introduction we have studied. More informations and how practically this is applicable in different kind of projects, we are going to looking after it. So transaction management, when you look at, it's more challenging. When you work with small application, it is not a problem. But when you work with a complex application, and which deals with multiple databases and in between the message brokers. Each and every time the messages are supposed to be updated with the broker module, right? So such kind of application when you deals with the transaction is a complex process. So microservice architecture, which divide each and every small set of actions or operations, which are put it under small services. So that is why multiple services will be there, but each service the updates are going to happen its own database. The small databases, the updates are going to happen, but at the same time each and every transactions are going to be maintained at all stages of transaction. So what's the need for a distributed transaction compared to the centralized one? So in a distribution, transactions are increased in microservice architectural style. So the database is distributed, and it may be available at different point of places and in different data centers. The data services may be ordered at one place, and maybe payment and the shipment details will be available at, and the warehouses will be in different places. So the orders will be processed by from different end based on the people location and the nearby location. If you have raised the order, okay, the business point of contact, they are having different warehouses. So these orders and queries will be processed from different end when they maintain this kind of a distributed transaction style. So it is straightforward when you compare with the distributed transaction, right? So each order and everything is validated as per this ACID rule. So that will be also there just to ensure the data consistency at each and every end. But when you just look at a simple order, it is little complicated in microservice architecture, because each and every transactions, every messages, everything is important. For example, in a food ordering services, like creating an order service itself, there are numerous service modules are going to be created, which is to follow each and every request process till it reaches to the end of the customer. So every request comes from there. So it is given here like there is an order controller module. When an order is created, okay, so that will come to an order service, right? So this order service module will handle the order request, and from the consumer end there are a lot of validation is going to take place, right? So the customer is a valid customer or not, and their address and the details are entered already. So the data will be read, and and they will calculate the distance from which this order is raised, as well as their location. All the details will be fetched. Also, when the customer paid online, okay, so for accounting services, when they paid online, their credit card and all the validity details will be verified at the same time, and also the feedback will be given back to them. In case if their account is invalid, or the credit card or the debit card is not having a sufficient balance, that order will be cancelled immediately, or it may be notified back to the customer that okay, insufficient balance is there. So such kind of message communication services are expected here. So creating an order itself, there are a lot of services which handle this kind of a small request to maintain data consistency across. When the customer details are valid, the payment informations are valid, okay, then only the ticket will be given back, or the ticket will be raised by the kitchen service, and that information communicate back to the customer end. So this is how creating an order operation which read from customer service and update the data and maintain consistency across. So the data consistency is important here across all the services, because every service should convey the same data back to the customer and validate each and every time. But there are some problem with when you perform such kind of distributed transaction style, because distribution transactions are not supported by different databases like NoSQL, MongoDB, Cassandra. But okay, there are then how can you implement such kind of a distribution transactions kind of an architecture? So IPC, what is because in distributed transaction everything is supposed to be synchronous, right? Everything is supposed to be yeah, shared resources here, right? So for example, in an when you raise an order in a particular shop, the shop is closing point time when the raise, okay, the last second when it is closed, okay, the order is also supposed to be closed. So in ways in such case, when you come when you just come up when you compare with the other technologies, other data sets, databases, this kind of services may not be available. So distribution transaction to commit all the participation services must be available. Like as I have told, the offering services from by whom, okay, from the other end, also the system is supposed to be available and to answer such kind of queries. So this kind of a problem is faced while you perform a distribution transaction. So additional support services also needed because in case the shop is closed but the customer is completing the order, okay, so the customer that he placed the order but the information is supposed to be given, the shop is closed at this point of time but you have raised the order by, because sometimes the customer may say that okay, when they started ordering at the time the shop was available, but when they complete, it may, okay, at the last minute, so they may come up, or when they raise the query or reporting back, you have to get the customer and with the possible answers, and you have to say that this is the reason why your order is rejected. But there are problems, such kind of problems which may not be handled by certain databases. So we are applying this Saga pattern to maintain this data consistency. Um, so Saga mechanism, which maintain the data consistency in microservice architecture when you use this distributed transaction style. So, but Saga is a sequence of local transactions. As I have told, every simple service is raised, the updates are going to be given back. So each local transaction updates the data within the single service using the familiar this ACID transaction framework. So the system initiates the first step, okay, till the completion of the last. Each and every messages are going to be triggered to the next local to initiate the next local transaction. So here the asynchronous message is going to be, because sometimes the customer may not be available at the other end. They may not be available in online, but they have raised the requests. But when the customers are maybe temporarily unavailable, they have turned their network off, or they may not be available for only few minutes, but the message is supposed to be sent back when they come back. And or you have to find your customer, for example, through calls, sometimes through message, you may thought like, okay, the customer should come to the doorstep to collect the product, but you thought through message you can communicate. So messages may not be opened by the customer, so you have to go for the next choice, that is calls, through calls. So but you have to reach the customer. So there are different ways of not only synchronous messaging, even though customer is not there or when they available on the next particular time, okay, you have to initiate such kind of messages through which you have to interact. So each local transactions commits its changes, Saga must be rolled back also. So for example, when the user want to cancel certain transactions temporarily, they have initiated before the money is reaching to the other end, they just want to cancel it. Maybe they have started the payment but they want to cancel it. So you have to okay, which are the objects are supposed to free up from the memory space, which are the, so rollback when you in Saga pattern, there are different type of architectural styles also there. This is mainly for microservice-based architecture, maintaining the data consistency across different databases which are updated by or connected with each and every service. Monolithic services, everything will be connected with a single database. But for here, each and every service, there is a single database, but uniformly, which is supposed to be maintained, and the data is supposed to be a distributed style. But see here, for each and everything, there is a request which is raised. So there are a lot of requests will be there. That is a problem with the Saga pattern also. So here comes, there are two different architectural styles or a pattern which is introduced, that is called choreography. Another one is orchestra. orchestration. So what is meant by choreography based style? There are some difference between these two as well. So these two styles we are going to study hereafter. So what is choreography based Saga pattern? So it is a distributed approach. Yes, it supports for distributed transaction, but orchestration style, which is centralized approach, and here it communicate directly which through the central mediator will be there. But here it is called as a central component, which is called orchestrator. They'll control the flow of this communication services. So anything and everything will be updated to this orchestrator. So when you want to go back and check the in between any point of failure, it is easy for it to manage and control, because it is very difficult for the developers to find out and go back where and which point this failure occurs, where which point this or where okay, for example, um, while you send a courier from one end to another end, each and every end, okay, the assurance is given, okay, your product reached to this location. So likewise, when you go back, okay, you can able to find out in which point a product is not moved, or which point a product transaction failure happens. So it is easy for us to find out now, because of this kind of patterns are introduced in the development side. So here, choreography style is a distributed approach. Services communicate directly with each other without a central mediator. This allows a decentralization, coordination, flexibility, and resilience. But it is difficult to debug and flow, because, as I have told, lot of request messages are generated. And orchestration style pattern, okay, it's a centralized approach, but here there is a central component called orchestrator, which manages the flow of communication services. And here also it is it's a linear order of execution, one by one event is completed, the next one is going to be triggered, after that only next, otherwise it is not going to happen. So this is how, so through that, okay, any single point of failure can be identified. But here multiple requests for each and everything, the request message is generated, so little difficult in debugging part. So this is the difference between monolithic architectural style and a Saga based pattern. There are two patterns. So in detail we are going to study about these two with the examples. For example, look at this order and payment service. So it's a microservice architectural style. Order service maintained by this database, and payment services are maintained by this database. Suppose there is a user called 101. Okay, the ID number is 101. He raised the order. Okay, so 101 raised the order for which product? This one. The price detail is 3000. Okay, so 3000 here. Okay, so uh, 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 okay, so the price also, okay, so he just bought a price of 3000, and the remaining balance is also available. Okay, and so you are saying that from their account, after deducting this 3000, 1000 is the amount updated back, and now we can say it's a success message and it is completed. So this is how the database are updated with particular details, and payment success or failure, which is going to be notified back. So when order is triggered, order event is created. When payment module, when the user started accessing, the payment event is triggered, and then once the payment is done, it is going to be recorded. Uh, okay, then one more transaction which is going to happen, like okay, so the customer is having only the balance is 1200, but they are okay, so 1000, the price of the product is 1200, and they are having okay, so they're raising the amount for 2000, and it is okay, so we have to intimate the user that okay, you have only balance that is 1200, and you cannot pay sufficient balance of this 2000 amount. So here you have to intimate the user that the status also it is updated with fail and it is cancelled, because sometimes the user may think that okay, they have a sufficient balance and they have started ordering, so you have to tell them why this transaction is cancelled because of this insufficient balance. So such kind of Saga patterns will get back to the user with the help of this kind of a microservice architecture. So Saga use compensating transaction to roll back some changes as well. Sometimes, okay, like due to downtime, order is raised by the payment module is not available, or the payment is updated at the time. Some servers are rebooted or okay updated. So because of that, the customers were stopped in between the transactions, and once again you have to inform that okay, roll back their transactions in case of any violation. For example, as I have told, the transaction is when the transaction is failed, the money is supposed to be refunded back to the customer's account as per the atomicity constraint, right? So the in Saga also this is automatically going to happen, the kind of a rollback, because each commit changes are happening in the local database. So it is easy for not in a centralized database. So it's easy for go backing to that particular point and making certain changes back to the customer's account. So you always the changes are acceptable, and it is supporting the user. Okay, so that is why in Paytm or in GPay or such kind of UPI platforms, when you do the transactions, so you no need to go back to the bank for the amount is not debited properly or credited properly. So automatically it is happening because of this Sagas module. And this Sagas can, okay, for example, here there is an application which is given. The Saga consists of the following local transactions. Consider there are different services. 6 services are there. Order service, sorry, 5 services. Okay, order service, consumer service, kitchen service. Each service is supposed to have a certain purpose, right? Okay, for example, order service is supposed to create an order, and it should give in case of any approval pending state as well, because sometimes okay, it's always it's waiting for other services as well. Consumer service, so verify the consumer can place an order or not, because he's a valid customer or not. Kitchen service, validate the order. Okay, each service depends upon the previous services. One service is completed, the next service events are going to start. So a service publishes a message when a local transaction complete. That means if first service is completed, then that initiate the next step of transactions. So this message triggers the next step within the Saga. So not only messaging, because Saga participants are loosely coupled, it guarantee that okay. So the modules are not loose, okay, tightly coupled. So loosely coupled. One is over, the next one is automatically initiates. And in between that, okay, sometimes a particular in between middle server is not working. The message broker will buffer this message once it is available, and then it will be delivered. So Saga, it seems straightforward, but there are few challenges also there. One of the challenges is lack of isolation between the Saga. Another one is rolling back changes when an error occurs. So that is also used to happen in between that. So because of that, successfully you can't complete because of some errors, it automatically rollbacks. So it cannot able to proceed further, and this is the problem with Saga. In between any problem occurs, if the transact, okay, so because of some violation, okay, you doesn't know what is the reason why this transaction is incomplete. So that is a problem with the Saga. And the consumer information is invalid, or the customer is not allowed to create orders, like this kind of a problem. So the customer data is invalid, okay, he can't able to create orders. So that's an example while you create the order Saga. So next, the restaurant information is invalid, or the restaurant is unable to accept orders. So that time also the Saga is not allowing for creating an order. The authorization of the consumer credit card also fails. Okay, so the future process also, whichever is started, all the process will be cut off. Okay, all the process will be stopped. So once again it go back to the first stage. From there the customer so it won't go back to the previous stage and asking them for entering the data once again, like UPI transaction. You cannot go back, right? Once the transaction is initiated, if there is a failure, then you have to go back to your order once again, and you cannot go back and restarted. So that's a problem with order saga, creating an order saga. In between any failure happens, that's a problem. So it automatically go back. So one point of time it is safe, but another point of time the customer may not repeat this process, right? So they may stop it, or they'll close the application, they'll exit from that, or it may create a fear among them. So that's a problem with this kind of local transaction failures. So that is why this is given. So that is why compensation of transaction is going to happen. For example, order services, each and every service is requested, the particular messages are going to be initiated. Compensation services, like one is rejected, that alone is supposed to be rejected, not all, right? So that is what it is given here, and you have to handle. But in Saga, okay, there is here as per this. So compensation sometimes needed. Sometimes the customer may say that uh, okay, like so how will you compensate such kind of services? Like you should not stop them completely. Instead, for example, here the credit card is not valid. Instead, you can give the option for them, again, keep them in the payment mode, will go for another options, right? So they can give this UPI transactions, or they can choose another net banking, or any debit card based transaction. So that is called the compensation based mechanisms, which are needed to be incorporated for sequencing. But anyway, once this is done, okay, it will just ask the user to proceed forward for the next transaction. So in case of such kind of things, okay, you have to compensate this transaction. So undo the updates made by this one, okay, like in between that you have to stop. Instead of stopping everything, okay, only these two particular stage alone you can stop, and you no need to ask the user to repeat all the other steps. Okay, so that is advisable. So coordinating Saga implementations consist of a logic that coordinate each and every steps, right? When Saga is initiated by the command, the coordination logic must select and tell the first Saga participant to execute a local transaction. Once the transaction completed, next task. So it will go in a sequential order. So as per the logic, so that is given under the topic of coordinating of sagas. And any local transactions fails, the saga must execute compensating transaction in reverse order. So because actually it will be stopped, right? So it will be terminated, but instead, okay, so you have to give the compensation transaction. Like you can give the option for them to choose other options or go for the previous steps. So there are different ways you can structure the saga logic with the help of choreography and orchestration. So what does mean by choreography? The decision making is distributed as well as sequential for the saga participants. So they primarily communicate by means of exchanging events. What is orchestration? Here there is a centralized orchestrator will be there, and this orchestrator send the command message to the saga, tell them that which operation they have to perform. But here it is distributed and this is centralized. Choreography is distributed and this is, so with the help of it, okay, this flow is going to be proceeded further in a sequential order, okay, by initiating different tasks. So we are going to see about choreography based saga. So far we have looked at saga and its properties with examples and what are the problems and what about saga's logic. And to coordinate this logic of a saga, this first pattern is initiated, that is choreography based saga. So this is there is no central coordinator, right? Okay, so here the saga participants are directed by a sequential message by exchanging the events. Okay, so one message is completed, or the next task will be initiated, but at the same time the updates are happening in the database. So triggers also useful here. For example, order service. When the customer raises an order, so in the broker module, it will be connected with the it creates an order events which are connected with each other events. Okay, so that will be initiated. So here there is no centralized event, a centralized coordinator. So when a particular event is called, that is going to create a particular task, and that will be connected with a particular event, and that particular service, this request will be initiated and that will be completed. For example, order events means, okay, for example, while you order, definitely order is supposed to be given back, the order is created. But here, from the consumer end, okay, the customer is verified. When okay, these two are done, then the ticket will be created in the kitchen. So kitchen, when it reaches, what are the messages supposed to be communicated, and behind that, what are the other services are supposed to be executed. And once it is done, then the next one is going to be created, and then finally you have to give an acknowledgement back that customer. Okay, so your order is successfully created. So behind click of a single button called order service, a lot of events are associated, and each event are distributed, and which will take place parallelly without okay, like one event is over, the next one is triggered, and automatically it is going to be. So this is the style of this is called happy path, like one by one step how it was executed. That when you write, okay, that is the statement one. As per this, the order service create an order in the approval pending state and publishes an order event. Consumer service consumes an order event, verifies the customer and places the places order and publishes a customer verified event. So one by one event is over. When this service, what is the service when it started, like kitchen service starts. Okay, this event validates this one. The ticket event create the pending state or updating the states, and then ticket event will be created. Accounting service. Likewise, one by one event, what is the task of each and every event? So the stage by stage events are going to be triggered, and in case of any failure, okay, it is easy for us to track, and even start when there is a rejection, so you can just give a compensation for them to complete the entire task. So this is how the happy path records the entire event, and this is how the path of execution. So here, where the rejection happened, that is in the last fifth step, it is authorization failure. So once you can go back and give the compensation to the user for completing this particular task to get the entire event, finish it in a way of successful manner. So Saga helps with the help of such kind of implementation. When the developer considers such kind of request, then it is easy for them to satisfy the user, like a flow of events. With the help of it, this is happening. The next one is reliable. This is Saga pattern is based on and reliable event based communication service. So each and every service which is going to happen in a step by step manner, and each and every step an ID will be created. It's easy for them to track at that particular point of time what happened, to analyze whether it is a failure or a success path of execution. Okay, so finally, what is the benefits of and benefits and drawbacks of this choreography based Saga pattern style of architecture? So simplicity, because we are creating an event and updating the event, deleting each and every time. Because once that is done, okay, the order event is deleted when it is approved and completed successfully. That order event is deleted. So loose coupling here, they have a direct knowledge about each and every steps, right? For example, ordering, or when we process the financial transaction, we have an order. So so each participants can get an order, get the knowledge of each and every steps, so it's easy for them to access the application. There are some drawbacks compared with the artistrian style, because artistrian there is a master, right, or orchestra, and he will initiate. So like the module will initiate, but here the single place in the code that defines the Saga, like everything will be written together, so it is very difficult, the code. And instead of choreography distributes the implementation of the Saga among services. It's difficult to sometimes developer how a particular Saga works. And there are some cyclic dependencies also there between the services, because it's create cyclic events. When you just look at the previous diagrams, you can able to understand, but it's very difficult to break the particular broker module to understand where or how this particular Saga works for the developer to rework again. So that's a problem with this choreography based side. Next Saga pattern is called orchestration based sagas. So orchestration, where orchestra class will be there, and which is the sole responsibility for the entire each and every interactions of Saga participations. So this orchestrator communicates with the participants with the help of a command. Maybe it is an asynchronous, maybe other end, the device or the system may not be, or the customer may not be available at the time, but a replay style interaction may be given back to them when they turn it on. To execute, it send command message and telling what operation, how it is executed. So with the help, it also the help of the replay message, it can able to understand. So here there is a message which determine which step are supposed to be performed. For example, this is an orchestration based style. The Saga participants can perform asynchronous with the help of a synchronous request and response message. So here the order service will be here. Okay, for example, so this create an arc like an order Saga orchestrator. So each and every time the reply is supposed to come back and it will initiate what is the next step for it. For example, verify the customer. So the customer service request channel pass the message for verifying the, okay, requesting the consumer service to verify. Once it is verified, the reply come back. Okay, once it is coming back, okay, it accessing for the next broker module for initiating the next request, creating the order with the help of the reply message. So after, based on the reply message only, okay, so the order is created. And once the order is created, okay, so the next kitchen service will receive this order request, and from the kitchen, okay, this ticket will be generated. Once the ticket is generated, and then only the payment will be done, and finally the reply will reaches back. So here the Saga orchestrator makes other participants to other services are a participant, right? So this participant services to give a request and reply. Based on that only it will work. If anyone has failed, okay, with the help of when there is a no response back or the reply message not arrived, so there the order stops. Okay, so the happy path of this kind of an orchestrator based style, how it is done, okay, it is given here. And for creating an order, so it works like a state chart, state machine diagram. So okay, one particular request comes, okay, that particular state will be activate, and then it will go to the next step. If the response is not arrayed, okay, or somewhere it is rejected, means that product will not go to the next step. So this is called a model of Saga is like a state machine because it describes all possible scenarios. So it works like a state chart based activities. So when it verifies, after that only, okay, so it's like a request and response based services. So that is orchestration based style. It is like a centralized network. Distributed structure is the previous one. And so with the help of this transactional messaging only, the entire orders are, the services are going to be controlled. So there are some benefits. So there are simple dependency, less coupling, and it simplifies the business logic. The domain objects also very simple, and people also, but they don't have knowledge, okay, so to initiate the, okay, so that's a problem. Here they have to find out where the failure occurred. For example, any financial transaction, when it is credited or debited, okay, that even each and every time it will not be given back to the okay, so to the customer, so if they have to go back to the manager module to access, okay, where this failure happened. So that is the problem with the orchestration. So domain knowledge, okay, when you consider there are benefit as well as the drawback. So risk of centralizing too much business logic is a problem. So it makes the, like a dump services what operation they have to do. So the only any problem went or anything went wrong, this orchestrator are responsible for the entire business logic. Okay, so that's a problem with orchestrator side. So with this help of these two architectural styles, you can implement the Saga-based pattern in a software development to track all the transactions and where it is stopped, and how the flow is supposed to be, some compensations are supposed to be given or not, okay, based on where the flow is stopped. You can able to identify with the help of compared to ACID traditional based management of data consistency style. When you implement Saga, you can find, okay, you can maintain and avoid this kind of a problem of data inconsistency and duplication, because each and every time, okay, so you can able to find out why and where the particular updation is not happen, and you can go back, that means like a rollback, and then you can yeah, start from there. So with the help of it, you can maintain uniformly the data in all the databases which are maintained by each and every service in the local transactions. So compared to traditional transaction management, this Saga is a microservice-based management style which maintains this data consistency over all the tables. So because of this particular two kind of architectural styles when you implement in your development part. Thank you.